So we have seen in our previous videos substitution theorem and how powerful it is that we can even derive Thevenin and Norton's theorem from substitution theorem and superposition theorem. So we saw that substitution theorem plus superposition theorem, they together gives Thevenin and Norton's theorem. So this is how powerful substitution theorem is. Now in this video I'm just going to have some fun with substitution theorem. This is only for fun and you may skip watching this video safely, no problem. Okay, so let's consider a very simple circuit. I have a battery like this, DC, plus minus, and then I connect it to a resistance R. Let this be V, and then what should be this current? This current I is equal to V by R according to Ohm's law. Okay, so that's as simple as that. Now let us apply substitution theorem. And substitute this R with a voltage source. Okay, so I will connect it to a voltage source instead of the resistance. And how should the polarity be? The current is flowing from top to bottom. That means this side, upper side is more positive than the lower side. So that's how I do it. This is plus, this is minus, this is plus, this is minus. Okay, and what should be the value of this? Let me call this V2. This was V in the original one. Now how should this V2 be? Now V2 should be equal to the voltage drop across this R in the original circuit. Okay, so voltage drop across R in this original circuit should be V2. So that means this will be I times R. So this will be I times R, but now I is equal to V by R. So V by R times R, so this is V. So V2 should be equal to V according to the substitution theorem. Okay, that's cool. Now let me ask, what is this current I in this new circuit? I expect you to be tempted to answer that no, I should be here equal to 0 because we have two equal voltages connected parallel face to face, so there should be no current flowing between them. And these are like two batteries connected with their positive terminals together and their negative terminals together, so there should be no current through it. I should be 0. But in the original circuit, I was equal to V by R. That was not equal to 0. If V was not 0, so I is not 0, but here I is 0. You might be tempted to say this. Does that mean this theorem, substitution theorem, is wrong? Come on, we have done so much with substitution theorem. We have proved Norton's and Thevenin's theorem, which we have used thousands of times in our electrical engineering life. But does that mean that this theorem is wrong? Because here it's I, here it's V by R. Is it funny? Is it funny? Is it really funny? I urge you to pause the video and think the answer yourself instead of waiting for me to give the answer. Let me give you another example, similar example, which might guide you to find the answer. Instead of taking a voltage source, let me take a current source and let this be I. The value is I. Now I connect it to a resistance which is R. So what will be the voltage? This voltage will be V will be equal to IR, definitely, right? Now let us apply substitution, and then I will replace this resistance now with a current source. Okay, and how should the direction be? In the original circuit, current was from top to bottom, so here it should also be top to bottom. And what should be the value of this current source? This should be equal to the current in the original circuit in this branch, which was I, definitely, so this should also be I. And this is obviously I, because this is unaltered. Okay, so this is what substitution theorem gives. Now definitely this current is I, but let me now ask the same question. V equal to what between these 2 points? So in the original circuit, V, this was equal to IR. What should be V here? There is no R, no resistance, no impedance. How do you decide this? V. Does that mean substitution theorem has something wrong? Okay. Pause the video, think yourself, and I give the answer, I give my thought now. So answer. Okay, so substitution theorem says that the solution of original circuit also satisfies substituted circuit. That's what substitution theorem says. Okay, but it doesn't say it. This is what substitution theorem says, but it never says that the solution of substituted circuit also is a solution of original circuit. This is what is not said. Okay, so let's see here. Here the solution for current was I. Now if I, and for which was equal to V by R. Now here what is I do not know. Let me put this value equal to V by R instead of putting 0. Does this satisfy this circuit? Yes, it does. It does, because this amount of current when flowing through this creates no voltage drop. There is no internal impedance. This is an ideal voltage source. Okay, so actually in this circuit, any amount of current can flow. In this circuit, I is anything. It can be 0 according to mathematics. Okay, according to pure mathematics, ideally if all the internal impedances are 0, exactly 0, then I can be anything. It can be 0, it can be V by R, it can be 5, 10,000, minus 100, anything, any number satisfies this circuit. Okay, in practical situation, internal impedances are not 0, there is slight non-zero internal impedance. Therefore, if these two voltages are equal, then there will be 0 current, definitely. In that case, first when the internal impedance is 0, truly 0, I can be anything. Any I solves this circuit. So that means this particular circuit has many solutions. This particular circuit has many solutions, whereas this one has only one solution. Okay, so this one solution will also be a solution here, but the many solutions, among them only one of them is the solution here, but not all of them. So the solution here will also be a solution here, but since it has many solutions, only one among them is a solution is equal to this, but not all of them. But if this circuit has only one solution, that means if it had some internal impedances, okay, in that case it would have only one solution, and then these two solutions will be equal. And similarly for this other example, once again you see, I mean, you might have already realized that V here can be anything. We cannot say what the values of V across this circuit. The current will be I definitely, because both these current sources which are in series are of same value I, so current will be I, but the, V can be anything. So V is equal to anything, any value. Any value is fine. So that means this one has many solutions, infinitely many solutions. But this one has only one solution. And this one, okay, and this one actually also belongs to this particular one solution, belongs to this set of many solutions. In cases where the substituted circuit has only one solution, then definitely the two solutions are equal. But when the substituted circuit, I mean, like this we can call a degenerated circuit, so it has many solutions, and only one of them is same as this, not all of them. That's my answer. Okay. So, but before I conclude, let me just say that this video is an advanced thought and is only for fun, and is definitely is not for all. Okay, if you are just beginner in this subject, this video is not for you. Safely forget this video, no problem. Thanks.